without further ado, let's give a big round of applause for our demonstrator, Caleb Kullman.
Okay, well, thank you for having me. It's been a while since I've been to one of the conferences here since I moved. I think the last time I was at a conference was maybe 2012, something like that. So for those of you that don't know me, I lived here in Colorado for 20 years, from 94 till 2014. I started blacksmithing as a farrier. I was a farrier out of Fort Collins, and so shod a lot of horses around this area, and then started my shop doing architectural work in Fort Collins, and then moved to Montrose like in 2005 and lived there till 2014. Had a shop there, and now I moved to Santa Fe, so I have my shop there. But early in my career, the RMS was a really crucial place that I learned a lot at conferences and workshops, so it's nice to come back and see a bunch of faces that I hadn't seen in a while. So I appreciate it. Yeah, I was president of the RMS, I don't know, maybe in 2007 or
14 years ago.
Yeah, a while ago. So anyway, I have a shop in Santa Fe. I do custom ironwork, for luxury homes basically, and I've been doing that pretty much full time since about 1998 or 99, something like that. And so that's what I do. So this morning I'm going to start out. I also have a few little items that I make and sell on my website. So one of those are these little bottle openers, and they're a wrought iron and steel laminate. So I'm going to just show the process for making these. So I'll get started. So I start with 1/4x1 material. So the first operation will be I'll create a shoulder in the material at an angle. So I'll just use a half-face blow, holding the material at an angle to a fairly sharp edge of the anvil. And this anvil's a little chipped, but there's a pretty sharp corner like right there. I hang about maybe 2.5, 3 inches over the edge, and then give a half-face blow. Come back and true up the sides. I'll take another heat and do the same thing and continue to work that down, but I'm just creating this shoulder. So I have a little bit of a recess for the wrought iron to sit in when I weld it on.
Caleb, would you hold that on the device?
Yeah.
Can you tell us why you're laminating the steel and the wrought iron?
Well, mostly because the wrought iron is more temperamental to work. Well, so some of it's aesthetic. I like the contrast in textures that I get between the two materials. And then some of it's just functional. You know, making that form out of wrought iron would be a lot more difficult than it would be to just make it out of steel. Punching that hole and drawing it down, the wrought iron would just delaminate or break. But I think mostly it's just the appearance, having those two textures and that contrast is why I started making them. You know, wherever I can find it. I mean, I bought some from other smiths that have retired. I have found it at the scrapyard. Just got that a little hot. It's a little bit difficult to come by, but it's out there. There are some people, you know, selling new material, but I haven't. Like in England, I think, is it the real wrought iron company, or there's someone out of England that's digging up anchor chain out of the Thames River and then re-rolling it into bar. But it's from England. It's super expensive. So usually, if you know what to look for, you can find it at the scrapyard on occasion, or. Yeah, it's real variable. So the wrought iron I'm going to use today, where is it? This is the round bar, and I'm not sure where this came from. I have, a few hundred pounds of it kind of stashed at the shop that I've collected over the years, but so I drew that down to a little smaller bar, but this is pretty good quality. It doesn't want to really split and delaminate. I think like old wagon tires are wrought iron oftentimes, and they're really low quality typically. So it just sort of depends. I'm making some door pulls. I build custom steel entry doors for people, and I am working on a couple doors now where I'm making the pulls. They're huge doors, 4 feet wide, 9 or 10 feet tall, and so they've got these big long bar pulls on them, and I'm making them out of wrought iron. And I found anchor chain from came out of Galveston, Texas, but Andrew Alexander, who's Blacksmith Tools on Instagram, he's got a bunch of it, and each link, they're 3.5-inch round links. And I think each link weighs 80 pounds. So, I got 3 of those links from him, and then cut them in half and straighten them and forge it down, and to make these big long, like 5-6 foot long pulls that end up at 1.5 inch round solid bar. Knife makers are using it a lot to clad their knives. So there are people selling it. Like there's a few people that are on Instagram that are selling it and stuff like that. So I want to end up at about half the thickness. So I'm pretty much there now.
So you're just thinning out the the whole length of this piece here.
Well, so it's, it's a bit of a taper, so it starts thinnest right below the shoulder, and then I didn't really thin it much out at the end. And so that just gives me a nice place to set the wrought iron in, and then when I weld it, I'm going to get a nice crisp angle or junction. I'm not going to get this kind of amorphous scarf where it would just sort of melt into the other one. I get a nice crisp line. Yeah. So sometimes I'll come in and do a little bit of filing to clean it up, but that actually turned out fairly cleanly, so I think I'm going to call that good. The wrought iron is a little bit wider than this bar, and it's a little bit too thick still, so I'm going to just draw it down just a little bit. I don't want the wrought iron to be too wide because I don't want a whole lot of it hanging over the edges, because when I weld it on the faces, that's what I'll do first. I'll weld the faces, and then when you turn it on edge, if you have too much sticking out, it'll want to fold over, and then you get a weld with the scarf going at a 90-degree angle, and that's bad because as you stretch the face, it's actually pulling the side away. So anytime you're forge welding, you don't want the material to wrap over an edge if you can avoid it. Do we have a whiteboard anywhere?
Yeah, it's sitting in.
So I don't have to do this.
The back of my shop.
The what?
You got the easel for it, no more.
You have a piece of sheet, just hot rolled sheet that I could just use a soapstone on, that we could set on there?
Got some whiteboard markers for you as well.
All right, now that'll work, I think. Huh. Yeah, so what I was trying to explain earlier about the scarf. So if we were to cut through and have a section of two bars that we're trying to forge weld together, if this bar really were sticking out, say, so I'd weld it this direction and that direction, and then when I turn it on edge, and I've got the two bars like this would want to fold over, and wrap around this corner. And then as soon as I start hammering on the faces again, the forces are pushing this direction and wanting to pull this scarf that's folded over the corner away. And then you keep working back and forth, and you just slowly are pushing that material that way and that material that way, and your weld fails. So you want to try to avoid having like a thin scarf wrapping a corner if you can. That's been my experience, at least.
So do you make the rod go far narrower than the flywheel?
I try to just get it right, pretty close to the dimension. The rod is a lot softer, so it actually will spread more. Yeah, so if it's a little undersized, it's not a problem. Well, the steel will not wrap around the rod, no, because of the physics of generally, I mean, unless it was way wider, but the rod tends to spread faster. But if you have two pieces of steel, the same holds, you want to try and keep your scarves or your two pieces in plane if you can. Nope. All right, so that should be fairly close. It's actually just a little bit narrower. Yeah, it'll be a little bit thicker, but I don't want it a whole lot thicker. No, No, I'm gonna butt the end of the rod into the shoulder on the steel. Both. I make these in coal. That's pretty close there. So it's drawn out a little bit. It's pretty much the same width. I'll cut the angle with a hot cut. I'll just carefully try and cut this and not drive my hot cut into the anvil with no cutting plate. Do a little hot rasping here, clean it up. All right, so that's should be ready to weld. I actually need to rasp a little more off the tip of it. The angle's not quite there. That's nice. So when I'm making these at the shop, I'll just do like 10 at a time and do every step, all 10 of them, and try to use as many power tools as I can to kind of expedite the process. So like this step, I'll mark the angle and then shear it on my iron worker and all that sort of stuff, so I don't monkey around with all this handwork, because you've got to be able to make them, reasonably fast. I sell them for $75, so I really need to be able to make them in like half an hour or 45 minutes, which I probably don't do, but that would be the goal. So that's pretty good fit there. Good enough. Okay, so now it's time to weld these guys up. So if I could get someone to help me hold this piece once I pull it out of the fire. So once I'll pull it out of the fire and I'll hand it to you, and if you would just kind of hold it like that, and then I'll have the other piece and lay it on top and weld it. I just do a drop tong weld. I mean, I do it, but sometimes I'll fit everything up and tack with the MIG welder back on the back end, just so that, it's not, I can just put it in the fire as a unit and it goes better. But the other day I was practicing. I hadn't made these in quite a while, so I was practicing earlier this week making one, and I just did a drop tong weld, and it actually, I stuck the weld. So we'll see if I can reproduce that. I'll bring these up to, a nice bright orange, and then flux them. I want to try and keep them as close to consistent temperatures, or keep both temps equal. I think that's one real trick with forge welding, doing a drop tong weld, is that both pieces are at the same temp when you pull them out of the fire. This is, I tried the Black Magic Flux. It's made by a guy named Jonathan Nedbor. And it seems to work pretty well. I've used anhydrous borax a lot. I think this stuff seems a little bit stickier just because I think it's got a bunch of iron powder in it. And that seems to work. The what? This stuff's real fine, so it doesn't seem to do that. All right, you about ready? We're getting there. It's a little hard to see with the sun. That was a little too hot. All right. So I just set the iron into that inlay, so I didn't quite get this forged down, but I'll do that this heat now. No, I just welded like the first inch, and then I'll work. Just want to get it stuck, and then I can take another heat or two and really make sure that everything's well stuck. So I had the steel. I had both pieces with the flux sides face up.
Right.
So then I brought the steel out and kept it in the same orientation. I just turned it and handed it off, and then I turned the wrought iron over.
When you go back to the fire here, the steel is
I'll flip it. I'll turn it, make sure everything's nice and even. What I'll do is I'll just take a partial heat to loosen the scale, brush it, reflux, put it back in, and take a welding heat. The air gate won't stay open. So I got that last bit stuck down a little better, and now I'll cut what's left of the iron off just so that it's not hanging out there. Just pulled that front of that weld up. No, it's there. I think I just tightened it a little and it's holding now. All right. Moving on. So I'm kind of trying to peer in to my pipe, see if I can see the flux bubbling and moving along the surface of the material. And when it's doing that, you know you're there. I'll do one more heat out at the end. I think the wrought iron generally is pretty forgiving. With forge welding, it's pretty easy to weld. You just have to make sure that you don't overwork it too cold once you have it welded up. That's, I think, the main thing, because it'll start to split and delaminate and do all that kind of stuff. All right. It's pretty good. Draw it out a little bit more at the end. I have a hook on my side of my anvil. I just tried to hang that on it. Okay, so it's pretty clean. You can see a little bit of the joint there, and some of that'll probably close up when I neck it down behind where the opener portion of the bottle opener will be. But I think it's pretty good. All right, so now what I'm going to do is do a little bit of layout and then cut the bar and start working the other end. So I give myself a little bit of space between the weld and where I punch the eye, but not a whole lot, like about 3/8 of an inch, maybe a little more. And then I give myself about 5/8 from the center of where I punch the hole out to the end of the bar where I'm going to cut it.
Does where you punch the eye, does that incorporate some of the wrought iron too, or only the steel?
No, it's just the steel. So I want to have this little bit of so I have this little section of steel here that I start with a pretty short section, but then when I neck this down and draw it out, it stretches, so we end up with more steel on the working end of the opener past the wrought iron. Well, I don't know. Maybe I will punch it first. Where did I put my center punch? All right, if I could get someone to strike for me, that would be nice. So we'll just take like a light marking hit to start, and then I'll look at it and make sure that I'm more or less over my mark, and then we'll drive it most of the way through from one side and then flip it. Yeah, look at that, it fits. All right. One more. Yep. Good. Okay. Thank you. All right, so got my little slug there that I'll knock off with the hammer. But that's kind of where we start. A little ragged, but it's not too bad. It'll be okay. It'll work. Oh, I don't know. What is that? Like close to ½ inch? Probably at one point it was sized to something specific, and now it's been ground and distorted and actually I'll have you help me drift it a little bit. So then I'll just drive the punch a little bit deeper, and so that I can get it over the tip of the horn. Yeah, thank you. So when I make these at the shop, I actually just punch an oblong hole on my iron worker, so it's super easy. I mean, I punch it lengthwise. So I take the bar and I've got my wrought iron there, and then I come in and I punch like a, I don't know, 3/8 by 1 slot with my iron worker, and then all you have to do is knock the corners off, and then I have a drift that starts as an oblong this way and then ends up like that, more or less, and I do that on the fly press. So it's a lot less work the way I have it set up to do when I'm doing these in a production run, but the end result is more or less the same. Oh, okay. Thanks. You got something against green? Oh. Good. Good. Okay, let's see. Is that gonna go? Not quite. Let's do one more heat. Yeah, that'll work. Good. And actually, while you're here, let's. Yeah, yeah, let's do that. I'm just trying to think about the best way to. A little bit more. Good, thank you. Okay, so that's where we end up. Now I can hook that over the tip of the horn and start, I can forge the little ears off there. Okay, moving on. It's warming up. Yeah, where's the mister? Where's the fan with the misters blowing it like? I had some friends visit Santa Fe last week from San Antonio, and they've had like almost 60 days over 100 this summer. It just sounds just insane. Okay, where's my hammer? So now I'll just start to kind of carefully forge these little owl ears out and draw this into a larger eye. And this is a little bit tricky just because you're working on a tapered horn, and you end up forging kind of a weird parallelogram shape. And I didn't want to roll any of that ragged stuff into it either, so I think I have it started pretty cleanly. You know, you just get in there and kind of clean it all up. Just makes life easier. So just back and forth, back and forth. And I don't want to thin it too much this way at this stage. I don't want to end up with a real kind of weak looking eye. So a lot of the work has to happen up on the distal end of it. Because I don't want to thin down in here anymore at the base of it. Because I want the base to be the thickest part, and then for it to taper as it comes up and around the eye, and have the thinnest portion be out here on the end.
By the base, you mean like 10 o'clock, 2 o'clock?
Yeah, like right where it comes off the main bar. I want it to be thickest there and thinnest out in the front. I think it just looks, I mean, it doesn't really matter from a functional standpoint. I just think it looks nicer if you've got a nice taper coming around the opener. Yeah.
Would a beard cup be big enough for you to soak the
Yeah. Yeah, because all it needs to do is soak the wrought iron. So I switched to a lighter hammer just so I can have a little more control of how much I narrow this down. So at this point now I'm going to quit forging out on the end, and I'm going to put my shoulder or my neck in it behind, and then I'll come back and finish. I'm almost done out there, but maybe not quite. So to draw this or to neck this down, I'll just work off the far side of the anvil with my heavier hammer and just try to do a tidy job of necking it down. I just use like a spring fuller in the shop when I do that.
There's one in that box.
It's probably not, it's not real big though, is it? No. Yeah, it's too small. Yeah, it's too small. I think first I'm gonna draw the back end down just a little bit so I can grab it with these tongs a little farther out to give myself a little more room. So I'll take a heat just behind the eye now. And I want it to be a fairly high heat because I'm still real close to that junction between the wrought iron and the steel, and I'm going to be forging a lot right in that area. And this is a spot where the weld will sometimes break as you start forging it down. I don't want to be in too big of a hurry here. I don't want to try and like get it all done in one heat and then risk having the weld fail. So I'll just do it again. Well, if I were in a gas forge, I wouldn't worry about burning the tip up so much. So I would just, it would all be okay. I just don't want to have it get so hot that it's, burns away. So I've got the far end, the opener end of it kind of through the other side of the fire, but I still worry it could get so hot because it's so thin that it would start sparking. Yeah. Yeah, because I want to work that weld at a welding heat, basically. Oh, you see that? Too big of a hammer.
So is your hammer flat on one side and curved?
Yeah, it's a ball face hammer. Basically a rounding hammer. Well, I'm basically back to where I was right before I crushed the end of it, but so I think that's more or less done there. I need to just finish shaping that, draw that down a little
Are
bit.
you trying to make it thicker right behind the eye? This thicker this way?
No, I don't really
Just
care.
try to
I'll
keep it
just try
all-
to keep it all
Okay,
the same, or even go from thin to thick a little bit that direction.
okay. Nice save.
Yeah. Beginner's luck. I demonstrated quite a bit, like in the, I don't know, around maybe 2008 to 2010. And then when my daughters were born, I just decided I didn't like it enough to warrant being traveling a lot, and just it always felt like you were, taking effort and time away from the business, yada yada yada. So I kind of didn't do any demonstrating for a long time, and then this year I demonstrated out in California this spring and now here. And when I was younger, I would really spend a huge amount of time preparing for my demos because I always wanted to make sure that I looked like I knew what I was doing in front of an audience, And now I guess I don't really care so much. Like, I mean, I just come out to guys and men and women some knowledge that I've gained and sort of show you what I've been working on. But I make mistakes all the time, and have to throw stuff away and things get frustrating and all that, and that's all part of it. And so I guess it's maybe a more honest way of presenting the work, is like, hey, I made one of these this week, and I hadn't made one since, I don't know, Christmas time, so it was like totally rusty, and I thought, oh, I'm going to go out here and just flub this. But that's all right. I'm secure with that. I mean, I don't want to come out totally unprepared because that's disrespectful or whatever. But I'm not going to like spend 40 hours making sure that I make everything perfectly, because that's just not how life kind of goes. I just need to draw a little bit out of this one right at the base. Try to get them to be sort of a matched, have some symmetry. The wrought can be a bit of a crapshoot too with the texture. So you probably, if you want to do some sort of work where you're using wrought iron and then want to etch it to reveal the texture, what I would recommend is etching the bar before you make what you're going to make, so you know what the grain looks like and like the scale of the grain. Because sometimes you'll get a bar that has a real fine grain and it's not very interesting, or the grain will be too coarse and it just looks kind of ugly. So if you do a little test etch, you can get an idea of what the scale of the grain of the particular bar is. So we'll see. I think this one on the opener I made earlier in the week, it was pretty nice at this scale. But you could also twist it. It's basically like Damascus. You can manipulate the grain in the same way that you can manipulate Damascus steel. So it's kind of cool that way. But it's not nearly as fussy, which is why I like it. You don't have to spend hours grinding and doing all that stuff that I don't want to do.
So if you're making a batch of those, do you test it before starting the batch?
Yeah, I would just check it if I'm using a bar that I hadn't used before. So that's reasonably symmetrical now as it comes off the parent bar. I'll do a little filing to clean up the neck, since at the shop I use it's like 1.5 inch diameter spring fuller, so I get a really nice necked transition without even really having to touch it with a hand hammer. But yeah, we'll go over that. I use muriatic acid. You just pop it in a fairly new muriatic, and maybe leave it for 8 hours or maybe overnight. You just kind of have to check it. It depends a lot on the temperature and a few other things like that, but it's really not hard. That's, like I said, that's why it's nice as compared with Damascus, where you're having to polish it and then, you know, use coffee or ferric chloride or whatever you're going to use. You just throw this in the muriatic and let it sit for a while and cook, and it works pretty nicely. Yeah. No, I just have I have kind of a little shallow tray that I put them in, and just make sure they're not like overlapping one another. No, because I don't really care about the backside. I just put them face up, and seems to work pretty well. Yeah, I do it outside. Yeah, I just have a vat kind of outside the shop and you know, I wear a respirator when I am handling it and handling these. It's nasty. I basically have a big drum of sort of used or weaker muriatic that I pickle things in and just dump stuff in a basket, and then I have a much smaller container that I put new muriatic in periodically, just change it out completely to etch stuff like this, so it cuts a lot faster. So I'll just kind of finish up the taper on the back side of it, and then we have to put the little divot in, and then we're basically done. So if I forge mostly on the back side, putting the wrought iron face down on the anvil, I get a nice flat surface for my finished piece. Nothing like sucking in a bunch of coal smoke on a Saturday morning. That's what I use in my shop. I mean, I like them. If they're designed and built well, they work really nicely. I had in Fort Collins, I built an overhead, hood that went over the whole forge, and I was constantly just eating smoke, because you have to. So like generally the rule of thumb for an overhead hood is that your pipe has to be 1/3 the corner to corner diameter of your hood. So if you have like a 4 foot by 3 foot hood, you've got to have a pipe that's 18 inches in diameter, and no one ever does that. They always put like a 12-inch pipe in, and they just don't draw enough ambient air to keep everything going away from your face up into the stack, you know. And you know, like in my shop, you have to sometimes, depending on which way the wind's blowing, you got to open one door and close another door and make sure that the kind of airflow through the shop is correct. But generally, I really like having side draft. I think they work well. It's kind of funny because I think a lot of European smiths, you know, the British use some side drafts, but like you see the Germans and people like that, they always have those big overhead hoods, and I kind of think, I guess they must know what they're doing, but maybe they don't. That looks pretty good there. So now there were a few little shuts in the wrought iron where it met the steel, and they've all but closed up. But the acid will probably reveal a little bit more of that once we etch. So you'll see a little bit of the transition in there, a little more.
You say when you're etching overnight?
You know, it depends. A lot of times I'll put them in and watch how much it's working. You can see the bubbles coming, and sometimes it'll really go fast, and it might take 4 hours or something. And other times, yeah, if it's cold, if the acid's maybe not brand new, whatever, you leave them in overnight. You can really over etch it, and then it gets a little bit, it can be kind of ugly. It just over etches, and the silica gets etched away, and you're left with kind of a lot of sharp ridges in the wrought, and it's not quite as nice. All right, so now I'll just go to the back to the other end, finish shaping it, and then knock the little divot in. No. I mean, Shahan, so I share my shop with Shahan Prol, who's a knife maker, and he studied knife making in Japan, and that's all, he burns charcoal, but I don't ever use it. What? Nah. I don't want to have to make charcoal, that's a pain in the butt. I mean, Shahan uses so much less fuel than I do, just because, you know, the knives are so small, and it would be a monumental operation to make enough charcoal to keep the forge for the volume of fuel that I need. Okay. So now the moment of truth. Can I actually see the center line? Let's hope. Yeah, it's just a little round punch, ball end punch. All right, so I can live with that. I punched it a little bit off center, but it'll probably still open a beer. And so after I finish the demo, I'll come back and do some file work and stuff, and then we'll etch it and look at it, see if it has to go overnight, we can do that. That's why I started with this, so just in case we needed to go longer with the etching.
Where do you get the coal for your shop?
Oh, that's a good question. I mean, years ago, Scott and I organized a big truckload of coal for the RMS, and I bought several tons, and I had some of that left over, and I just kind of burned through that like a year ago. So I went down to Rob Gunter is selling some coal that he gets from Hesperus. I had bought coal when I was in Montrose. I would drive over to Hesperus and just get a truckload of coal. But it wasn't my favorite, but it was cheap. I could get a ton for $55 and 3 hours of driving or whatever. So
You get about a ton for $100 up out of the 20-mile mine if
but the coal wasn't great. So then I bought some of that Kentucky coal and I actually mixed them, and that was okay when I put some better coal in with it. Then Rob Gunter convinced me that he's been buying coal out of Hesperus and he's getting all the shale out of it because he's buying the big lump stuff and then he's crushing it down to a smaller size, and he said it's really nice. So I bought recently some from him, but I don't like it. It's like it doesn't coke real well, and it just has lots of volatile stuff in it, so I get this huge bunch of flame and I never have any coke. So I think I'm going to just bite the bullet and buy a couple tons from, like, what is it, Penn Coal Company or something in Pennsylvania. I don't know, they're around there somewhere that they're selling it in bags. But it's going to cost, I think I got a quote recently and it was $600 or $700 for the ton in bags, and then like something ridiculous, $950 to ship a ton, so, but in the end, I don't burn a lot, I don't burn tons of coal, so it'd be probably I burn through maybe a ton a year or something, so $1,500 is not a huge expense given the operation. Another blacksmith in Santa Fe has a bunch of mid-continent coal from before that mine up by Aspen shut down, and he wants to sell me some, so I might buy some from that. I don't know. It's a bit of a problem.
So you got coal from Hesperus when you were down in Montrose?
Yeah, for a while I was using that just because it was there and it was cheap.
Any from Somerset or any of those mines over there?
They never were interested in selling small quantity, And I heard that it wasn't as good as the stuff at Hesperus, but okay. Yes.
How do you identify iron if you're in the scrapyard looking for it? I mean, somebody sells it to you, it's
Yeah.
gotta be iron. But
So if you're in the scrapyard and you can't, a lot of times you'll see bars that are broken, like in the process of breaking down the scrap, they'll cut it or bend it, and you'll see the fibers, because when you really sharply bend wrought, it'll delaminate and you'll see the fibers. Okay. Sometimes if it's real old and rusty, the rust will reveal the fiber structure. Sometimes you just have to guess based on what you're looking at. Like if it's a wagon tire, chances are pretty good that it's wrought iron because that's the period that stuff was made out of wrought iron. Or if you know that it was like, oh, it's a bridge, a lot of times you hear people salvaging bridges from the 1800s. Say a railroad trestle in your area that was built in 1890, they cut that down. You can bet that that's all wrought iron because steel wasn't used widely until after 1893, I think. So. Yeah, I mean, any like old wagon parts, if it's a truly old wagon, they're going to be wrought iron. But it is a crapshoot. You got to just look at it, see if you can see any grains anywhere. And, you know, sometimes stuff was cast back then, so if it looks cast and not forged, it's not going to be wrought iron. But all right. So how long did that take? Hour and 45 minutes. Damn, that's all I've got for you. Yeah. Okay, so the next order of business is I just threw together this barbecue fork this week to just show some different techniques, and so I'll jump into this. You know, this was just I just made this kind of. I didn't do a drawing or anything, so it's a little bit big here. I think I'll make it a little smaller, but I kind of like this reveal of the heavy texture below and then the flat bar above. So we'll start in on this now.
So that's just chisel?
It's folded over. It's forge welded. So I start with a longer bar, texture one section, and draw that down, and then fold it over and weld it. It's like magic.